Okay. Okay, so I will present SQRS, which is Command Query Responsibility Segregation. It comes somehow as a continuation of what Christian explained about event sourcing last week. So first of all, what is CQRS? It's a design pattern, was inspired from CQS, which is command query separation, that states that a method should either change a state of an object or return a result. What CQRS adds new, it's that it separates the query and the commands objects to retrieve and modify the data. So as an example, this is a simple example of CQS implementation. We can see that we have only one class that has both the query method but also the commands method. CQRS separates these two. So then we have two different classes. One it's only for querying and the other one it's only for commands. A simple class diagram for query and command in CQRS is as follows. We have the user interface that communicates with the data store through the command model, and the data comes to the user interface to the query model. The advantages is that those two classes can operate independently, none of them having any dependencies on the other. We can have multiple query and command classes, each of them with their own methods. And so we can have a simple query method, but also we can have another one that has more complex queries that can be performed. Also, the separations are very good when we are dealing with performance issues because we can optimize them separately. So, what's CQRS in event sourcing? As Christian explained you last time, event sourcing is a design pattern, but we need to integrate it with CQRS when building systems that have distributed data and needs to be high performance and scalable. um, Event sourcing allows CQRS to have separate data store or database for consistency, and the data tracking is very easy and also easy to maintain. So example of systems that would benefit over this are systems that have different database for editing data and reporting data, and those two can be synced using CQRS. Also, a system that has a database used only for editing, but another database for query operations. So in event sourcing, the schema it's a little bit more complex. We see that the user interface communicate with the command bus and command handler to get the commands from the repository and from the database, and also the query are taking the events and then denormalize it, take it to the user interface. So on the query sides, we are taking the DTOs directly from the storage. We can have one single call that contains all the data we need. The read layer is connected to the database, and for high performance, the data should be denormalized. On command side, each command is created by the client application, and basically commands are some messages that perform a certain actions, and each command is handled by his command handlers. Makes sense. So what's a command handler? All the commands that are triggered will be sent to a command bus that will execute the appropriate domain behavior, and the command handler will have a connection to the repository to provide the ability to load entity. So basically, when we want, for example, to store something in the database, we just trigger a command, and in this architecture, the command will trigger an event that will have all the data that needs to be. So as a resume, the command handler is basically performing the following steps. It receives the command instance. It validates that the command exists and it's properly constructed. It locates the aggregate instance that is target of the command, and it invokes the appropriate method to the aggregate, passing the parameter from the command. And then all of that will be stored. So when can we use SQRS? When we have highly collaborative data and large multi-user systems. Uh, it is very helpful when we want to track and log historical changes also. Uh, we can achieve very good performance both on reading and writing because we can optimize them separately. It's very useful when we have difficult business logics, and with SQRS we can split developing tasks between teams with defined interfaces. Questions?
For example, if you trigger multiple insert commands
Yes.
to write into database, of course you trigger an event and perform the actions. How the client, the user, will be notified if data has inserted or through queries?
Well, the query will take the latest version of the event. So each event has a version.
To get the latest query, I need to know when the insert has been done.
Yeah, it actually depends on how you implement CQRS, because this only says you have separate read model and a write model, right? But you can implement it transactionally, so you wait for the command you execute, and then you would have the result immediately. Or you can have parts of the system which are fire and forget. So you fire the command into the command bus, and you know it's going to be executed at one point. So you'd have data to read at one point, so it's eventually consistent. What you usually do is flag some process that it's in progress. You just show the user it's in progress. So you need to wait if it's a long running process. But yeah, it actually depends. You can have separate parts of the system, either transactional or fire and forget. So it depends on what you need.
Okay, thank you very much.
I like that. What's all this is also useful when you need to have. Não, podes escrever. So this is also useful when you have stackable behaviors for your commands. For example, let's say you have a system in which you have roles for your users. Just some of the roles are able to execute some type of command. Right? You don't want to implement this logic of authorizing users in the command handlers themselves. So you can create a generic wrapper for all of the command handlers which deals with this. So if your command comes in, you have a command comes in the system into the system, it's not going to go directly to the handler. Fuck. Okay, so a command comes into the system, it's not going to go directly to the handler. it's gonna go through a decorator of that handler. If that passes, it's gonna move on. So you can have stackable behavior for that command. Right? This is decorate authorization decorator. Then you would have like a logging one. Then the original command one handler. So it's very easy to do this, right? Again, for this part here, you can see here we have separate stores for the write model and for the read model, but that's not a necessity. If you have this separation, imagine what would you do if you want to check for, let's say, duplicate user name. Because you inside commands you can't query the read model because you don't know if that's up to date or not. So you need other mechanisms to check for this. You would probably have right beside the repository another service which will keep with what? So you would have a separate service which would keep these kind of things always up to date. For example, users. You'd have a registry for the usernames that already exist, because that's the thing that you can query from the read model, because it's on that side. It's always up to date. It's going to take longer, for example, if you have lots of users, because you can't fire and forget commands, but you'd have consistency. So this is a pattern that you could mix and match with some other things to make it work for you. It's not, if you go SQRS doesn't mean you need to be fully using this. You would have custom behaviors where you need them. Yeah, that's it. Any questions? No questions? Okay.